Hello everyone, so today we will be covering chapter 3 of physics class 7 ICSE. This chapter is really interesting. It's about energy, it's about work, and these energy and work terms comes very often in physics, and you need to be really clear about these terms, what are these and how they work and so on. So chapter 3 is about energy, but before I go and explain what is energy, you should know one more term, which is work. So come on. So you should know what is work. Okay, basically work is the basically in terms of physics, work is something when work, it is said when work is done. So work is done when something moves. What do I mean by that? So simply I'm saying work is done when something moves. So suppose there is a body A. This is A, and suppose with respect to time, so this was the body was A and it was 9 p.m. By 10 p.m. the body moved from this position to this position, and it's 9:50 p.m. Suppose. So with respect to time, there has been a movement of the body. Okay, so this displacement of the body, I have already taught about distance and displacement. You can go and watch those videos also, but here we are talking about work. So work is done when a body is displaced. Now suppose this object A was in this position, and after some time they went to this position. So I say that work is done on object A, or object A has done some work if it is a human being or some other organism. But work is done when something moves. Simply I can also write work is done when anything is displaced. So if you displace something, what do you mean by displacement? Displacement means moving a body from one position to another position. That's simply what displacement is. But I'm not going to the definitions of displacement. Displacement has another definition. Displacement is the shortest distance between 2 points. Okay, so here work is done when something moves, or something has moved from one position to another position. Or I can also say work is done when something is in motion. So if something does not move, suppose there is a man, okay, a worker, okay, and he's a labor working in a company, and he is doing the labor job. Basically he is picking up bricks. Okay, it doesn't look like bricks, but still, just suppose those are bricks. So if he picks up those bricks in his head, okay, on his head, if he picks up those bricks on his head, so this picking up of bricks, I will say no work has been done. But if he moves from this position to this position, so the brick is also moving along with him. So when that happens, I'll say work has been done. So basically, until and unless a body moves from position A to position B, or from one position to another position, work is not done. So work is only done when a body is moved from one position to another position. Simply that is the case. So in terms of the formula or the derivation of work, what is work? I can say work is equals to the force applied multiplied with distance, or the displacement. So if W is equals to, capital W is equals to F into D. In some books you will also find F into small s. This s means displacement and nothing else. So what is this force? Again, there's a football. Okay, the football is placed in a ground. Ground is not touching. Okay, suppose there is a football or simply a ball which is placed on the ground, and now you have applied a force on this direction. So in which direction you are applying? You are applying the force from left side to right side. So here you are applying a force. Now you are applying a force to one particular direction, isn't it? And that force has a magnitude. Suppose you are applying 10 Newton force. 10 Newton of force. Force is measured in newtons. So 10 Newton of force you are applying from this direction, and what will happen? So you are applying force means what? You are kicking the ball, you are just punching the ball, you are doing something, you are applying force. So 10 Newton of force, suppose you are kicking the ball and the ball starts moving in this direction, isn't it? The ball will start moving. Now suppose after some distance, due to some friction, we all know that ground has some friction, ball will not continuously move, it will stop at one point. So it stops at this point. So this was position B and this position A. So the ball has moved from position A to position B. So this is the S, and the force applied is 10 Newton. Suppose this S is 10 meter. Okay, so what will be the work done? The work done will be 10 Newton into 10 meter, which is 100 Newton meter. Now 100 Newton meter is equals to joule, means 1 Newton meter is equals to 1 joule. So 100 Newton meter, I can also write 100 joule. So from here we also find out that the SI unit of work is joule. So SI unit of work is joule, denoted by capital J. Now please note down all of these are very important. You have to note it down in your copy, and I always continuously repeat this on my in my videos that you have to write down all of these notes. Just note it down. Obviously some extra notes will be provided in the description box, but still when you read and you keep on writing notes, that is very useful, because that will help you to understand the topic. And not just that, you can also modify these notes. You can make these notes your own. You just modify them. If I'm writing A and A, you can write A and Z. There is no problem. Okay, the thing is you should understand what you are writing, not me. Okay, so write all of these, and you are totally free to modify any of these, just to make it more easier for you. Now everything is done, I guess. Okay, so how am I getting joule? Many of you might ask. Sorry for being really fast about on this topic, but how joule, the SI unit of joule, SI unit of work is joule. Simply work is equals to force into distance, isn't it? F is equal to force into distance. Sorry, work is equals to force into distance. What is the SI unit of force? SI unit of force is Newton, and SI unit of displacement is meter. So SI unit of work is also Newton meter. Newton meter is said as joule. So 1 joule is equals to 1 Newton meter. Keep that in mind. Okay, so this thing, 1 joule is equals to 1 Newton meter. Keep this thing in mind. Now this was all of work. You might get some equations, some problems based on work. You might also get the derivation of from where you got the joule symbol, and what is the SI unit of work. You might also get those derivations. So I just shown you what are the derivation. Just do that will be very easy for you. Now moving forward, we also have some other things to discuss, which is energy. Okay, so it's very simple, and nothing is such tough. You might get it tough, but it's not. So what is energy? Okay, what is this energy? Simply energy, let me erase this. Now energy is the ability to do work. You see, work and energy both are related terms. So what is energy? Energy is the ability to do work. So suppose there is a person, again we have this person, and let us give a name to this person. So Raju Kaku. Raju Kaku. So Raju Kaku. So Kaku, what he is doing is basically he is lifting up some bricks, pieces of bricks. Okay. So if he lifts up those pieces of bricks, he puts in his head all of those pieces, and he starts moving in a straight line. After reaching position B, he was in position A. After reaching position B, he stops. So over here, our Raju Kaku stops, and he has done his work. Now, to do this work, which we can find was work equals to F into D, or you can also say F into small s. So we have the equation for that. So when we find the work, how much work is done, to do that work, obviously he needs some energy. Raju Kaku requires energy to do a certain amount of work. Now, how to calculate that energy? It's very simple. Energy is the ability to do work. So suppose 100 joule of work is done, that means energy is also required 100 joule. Simply that's it. So the amount of work done is equals to the amount of energy spent. You see the relation over here? You're doing some work. To do that work, you need some energy. If you calculate the work, you get the energy. It's that simple. Okay, so you got the concept of energy. Energy is equals to work done. Okay, so energy, I can say energy is equals to, okay, energy is equals to work done. So the amount of work you do is the amount of energy you have already spent doing that work. So it's easy. So definitely, if amount of energy is energy is equals to work done, therefore the SI unit of energy will be equal to SI unit of work, which is joule. So SI unit of energy, SI unit is also equals to joule, represented by capital J. Yes, capital J. Don't think it's messed up. It's, I guess, quite good. Sorry for that. Okay, now let's move on to the next topic. Now there are different forms of energy. Okay, various forms of energy, and I will also be discussing about the conservation of energy law. But right now, let us discuss about the two main types of energy that you will get in your ICSE books, and those are very important. One is kinetic energy and one is potential energy. So these two terms, kinetic energy and potential energy, these two terms are very important. You need to know really clearly what is kinetic energy, what is potential energy. First of all, write this down, and whatever I'm writing, just copy it. So write beside kinetic energy, released energy. Okay, I'm really worse at writing in boards. My handwriting is just not good. Released energy. And beside potential energy, you write stored energy. Okay, so kinetic energy is basically released energy, potential energy is basically stored energy. Let me give you an example and explain what these both terms are. So suppose I have a ball, and now I've thrown this ball up, really up high, and then after going to a certain height, the ball comes down again. Okay, so I had a ball, isn't it? I threw the ball up and it went, suppose, 20 meters high. Okay, 20 meters high. After reaching a particular height, the ball stopped at this point, okay, the ball will stop for few seconds, for few milliseconds, okay, the ball will stop, and then the ball will start falling downwards. Now pay attention. When I threw the ball, I had some energy within me. I had a type of energy, kind of energy, a certain amount of energy that I blew in the ball. Not blew, I just transferred that energy into the ball. That is why the ball went up. So I had some certain amount of energy. And when I threw the ball, my energy got transferred into this ball. Okay, so this ball got the energy that I had in my hand. Now the ball started going up. Now while it was going up, it was having, means I basically transferred kinetic energy. So Ke, basically I gave the ball some kinetic energy. Kinetic energy means the energy the ball required to go up, to go against gravity. Okay, so I gave the ball some kinetic energy and it went up. So it was going up and up and up and up and up, and slowly and slowly and slowly and slowly the kinetic energy was decreasing. Because if the kinetic energy continuously goes on, or if it doesn't decrease, what will happen eventually is the ball will keep on moving. Okay, so therefore due to friction, due to gravity, friction of the air basically, so due to gravity the kinetic energy was dropping down, and the kinetic energy was getting converted to potential energy. Means my kinetic energy that I gave to the ball or transferred to the ball was getting converted to potential energy, which is stored energy, that is getting stored in the ball. So up to certain height the ball is getting potential energy. Means kinetic energy is decreasing and potential energy is increasing when it's going high, means going up. Now when that is happening, when the ball reaches this point, this position, okay, the maximum height, the potential energy is also maximum. Okay, in the maximum height the potential energy is also maximum. In that maximum height, when the ball means eventually has zero kinetic energy, the ball now starts going down. And when that happens, the potential energy gets converted to kinetic energy. That means potential energy decreases and kinetic energy increases until the ball hits the ground. Suppose here is the ground, and all of that energy is given to the ground, and in the end you hear a sound. Suppose this is your air, which doesn't look like an air, but still suppose it is an air, and I'm really bad at drawing, but suppose this is your air, and here you get ultimately the sound of the ball hitting the ground. And not just that, the ball also absorbs some of that energy, the ground absorbs some of that energy, some of that energy is also converted into heat energy. Now why that happens we'll be discussing. Now I have to say it always, it's finished. This is potential energy, that is kinetic energy. Any confusion, comment down below, I will be answering all of that. Now everything is done. Note it down, my dear students, because I know you won't note it down until and unless I say it 100 times. Just do it. It's good for you, not for me. Okay, done. Now let's move towards the next topic, which is conversion. Now let's move towards the next topic, which is the conservation of energy. Does it sound filmy? I don't think so, but still, let's move. It's really hot in here. I'm not even switching on the fan, because you know what, if I switch on the fan you will hear the noise and that won't be good for the video. So doing all of these sacrifices for you, basically doing for me also, because I leave it. Okay, so conservation of energy. Conservation of energy. Sounds interesting? Doesn't sound interesting? It will sound interesting now. Now, conservation of energy, law of conservation of energy, basically it's a law, okay? So, law of conservation of energy. So, the conservation of energy basically states that energy, which is really fantastic term, energy can neither, N-E-I-T-H-E-R, neither be created nor destroyed. But it can only be transferred from one form to another. Look at it. It sounds really nice, isn't it? So it says that energy can neither be created nor destroyed. I think you might have heard if you watch Nat Geographic or Discovery Channel, but still, energy can neither be created nor destroyed. It can only be transferred from one form to another. Very interesting. You know why? Because you see, the amount of energy in this universe is actually finite. Now, universe, as we say, is like infinite, but the amount of energy is finite. Well, the universe is also finite, it has an end point, but still, energy can neither be created nor destroyed. This is very interesting fact. So, whatever energy is there in the universe, okay, leave out the universe, I guess that will confuse you. Let me give an example. That will be helpful. Suppose you have a ball. Why always you have a ball? Why can't you have a cycle or something else? Ball is easy to explain. Okay, suppose you have a ball and you kick the ball. You have a very nice leg and you kick the ball. You'll never find such a nice leg in your whole life. Now you kick the ball and the ball starts moving forward. Isn't it? What is happening here? After some point the ball will stop, okay? So after some time the ball eventually stops. What is happening? Can you just pay attention a little bit? Basically, I hit the ball with a force. So suppose 12 Newton. I hit the ball with a force of 12 Newton. The ball starts moving. After a certain point, the ball stops. So the ball is at rest. Okay. What is happening is, I transferred 12 Newton of energy from my leg to the ball. The ball takes that energy because that is the kinetic energy. So the ball starts moving forward, moving in a particular direction. The ball starts moving in this direction, and due to friction while the ball was moving, it was also experiencing a retarding force. What is retarding force and all of that? You don't need to understand about it. Just remember, friction was there. Obviously, if you just take for example your hands, when you rub your hands, you have friction. You are generating friction. Because of friction, your palms are getting warm or sometimes very hot. But this is what's happening. When you hit the ball is also getting friction, which is forcing the ball to reduce some of the energy. Means whatever the energy, 12 Newton of energy, the ball gets retarded backwards, and because of that the ball started slowing down. The energy decreases, the kinetic energy decreases. Why it decreases? Where does it goes? It goes to the ground. I mean, the ground absorbs it because the friction is working. Now, because of that, there are many factors, but still let us consider just friction. So because the ball is retarding back, because due to the friction the ball is slowing down, and after some time it's coming at rest, energy was always the same throughout the whole journey of this ball. How? I applied 12 Newton of force. The ball started moving and also slowing down. After some time, the ball comes at rest. When the ball comes at rest, it has zero kinetic energy. But what about the 12 Newton force? What about this energy? Where does it go? This energy was somewhat reduced in the friction, somewhat also reduced because the ground and the ball was absorbing some of the energy. It was also reduced because of the airflow, or just if you still ignore the airflow, the ball has lost all of that energy in the whole process. But still, in the whole process, the ball has not gained any energy, nor it has suddenly lost an energy. Why am I saying that? Like, the ball, while it was moving, I applied 12 Newton force. So when it came here in the middle, suddenly it didn't get 13 or 14 Newton of force. 12 Newton was 12 Newton. Rather, it was decreasing. Okay, it was decreasing in a linear way. But also, it didn't suddenly just lost some energy into the vast space. Like, the ball was moving, we all know that because of friction, the friction was reducing the energy, but it didn't got a huge leap of reduced energy suddenly. What do I mean? Means when the ball was moving, suddenly it didn't happen that after coming this point, the ball suddenly has 2 Newton of energy left. Where does the rest of the energy go? It was not gone in the friction. It was not gone in the absorbing process of the ball and the ground. So where does the energy go? That actually breaks the law of conservation of energy. And that kind of experiments, we can say that it does not obey the laws of physics. But in real life, that does not happen. In real life, we experience this law of conservation of energy taking place everywhere in the whole universe. So there is this last concept in this whole chapter which is left, and we call it hydroelectricity. How is my handwriting now? It looks really good, isn't it? But still, hydroelectricity. What is hydroelectricity? Basically, the energy, or not energy, okay, electricity. Let us say electricity. The electricity created due to the flow of water. So the electricity created due to the flow of water is called hydroelectricity. Take for example your modern dams, okay? So for example, suppose this is your water reservoir, okay? So this is water of some river, and this is the dam. Over here you are basically walking or passing by. This is the bridge, okay? This is the dam actually. So now basically this is what the mechanism is. So these are gates, okay? So these are some of the gates over here. Sometimes when when they need electricity, when people need electricity, what they do is they open these gates and water starts coming in, okay? So water starts coming in. Now inside of these dams there are turbines, big turbines or big, dynamos. Now how to draw these? Suppose if it is like that, I cannot just show it to in a two-dimensional plane, but still try to understand. They are big dynamos. When the water flows over those dynamos, the dynamos starts rotating, okay? So the dynamo, if this is the dynamo starts rotating in this direction, okay? Now when it starts rotating, what happens? This axle is connected. This axle of the dynamo is somehow connected to a big what is it called? भूल ही गया. So this axle of this dynamo, the axle of the dynamo is generating some of the axle of the dynamo is connected to a big generator. Okay, so there is a big generator. Now this generator, when the axle moves very fast, the generator actually produces electricity. How it's produced, you don't need to know. Produces electricity. But still, if you want to know, you can find various videos, various animated videos which will be really easy to understand. So you can go and search on YouTube. So produces this dynamo. Wire is connected. That wire is connected to the generator. The generator produces electricity. And here we find that because of the flow of water, due to the flow of water, electricity is produced. So basically, when electricity is produced due to the flow of water, that is called hydroelectricity. It's just that, nothing else. You don't need to know anything more, in detail about all of this. So this was all of the concept of this chapter. Chapter 3, energy, hydroelectricity, kinetic energy, potential energy, work, on all of that. I guess this was all of it. I don't remember anything else from the chapter. This was all of the basic concepts from chapter 3. And definitely, if you want to understand the chapter deeply, you have to read the book, you have to watch some videos, you have to take help from your elders. That will be really helpful. And you have to take notes. That's very important. Take notes, try to understand what you have learned. I always say, and I'll continuously keep on saying that in each and every video, that do not focus on getting higher marks on exams. Okay? When exams are going on, your main focus is how do I get marks? Do not do that. If you want to get marks, just focus on what you're interested in. If you're really interested in the chapter, the chances are you will read the chapter more often, you will do more practice based on the chapters, do question answers, you will do more diagrams, more formulas, more questions, more numericals. When you do that, you have a proper concept, proper idea of the chapter. And when that happens, you will definitely score good marks. So do not focus on scoring good marks. Focus on getting the concept really clear in your mind. And try evoking some interest on the chapter, or not only just in physics, but in chemistry, biology, mathematics, history, geography. Try doing that. Rather than focusing on marks, if you do this, that will be really helpful. Now, before ending the video, let me say you one more thing. That is, if you're not following me on Instagram, in this Instagram ID, Gulfamusan official, if you're not following me, you're missing out a huge deal. Really, believe me, you're missing out a huge deal. If you have Instagram, if you have Facebook, if you have Twitter, any of these three, go and follow me there. Why? The reason is very simple. You will get personalized notes. You will get personalized Q&A from me. Ask me any question over there. I'm always active. Not always, but basically all the time I'm active over there. Okay, you will also get to know about behind the scenes, what is going on behind making these videos. I'm not just coming in front of the camera and recording all of this. I am taking down notes, I'm making some extra question answers, and I'm preparing some question papers for you all. So just go and follow me on Instagram if possible. If you don't have the app, if you do not have any Instagram ID, Instagram account or Facebook account, you don't need to download it. YouTube is enough for you. Just go in the comment sections below. Comment as much as possible, comment as many questions as much as you want, and I will answer all of those. That's that easy. Now, if you are not supporting me on Patreon, please do support me on Patreon, because whatever video I'm making it for free. I'm not getting any money from anyone. So if you help me on Patreon, if you really like what I'm doing, if you really love the subjects that I'm teaching, if you really love the way I'm teaching, go on Patreon, support me over there. It will be really nice of you. Thank you so much, and see you in the next video.